Good morning, Sandeep sir.
Morning, Anushri.
How are you, sir?
I'm good.
So maybe in 2-3 minutes we can start if you want. There are around 10 participants.
Let's wait for 2-3 minutes. Yeah.
Okay, sir. Sir, around 10:35 we can start.
Sure, Anushri.
Okay, sir. Good morning, sir.
Morning, Anushri.
So you're clearly audible and visible as well. So we can maybe check your presentation if you share them,
Sure.
and then we will start it. Yes, sir, it is.
Is it visible?
Visible very clearly. Yes, sir.
Okay, great.
So, sir, for now, you can stop sharing. I'll just give a brief about you, and then we can start. Shalia, are you there?
Yes, ma'am.
So we will start the webinar. So maybe we can do the recording.
Okay, ma'am.
Okay. Shall I please begin the recording if possible?
The webinar is live now.
Okay. All right. So, a very good morning to everyone. Myself, Anushri, and I will be the host for today's webinar. So, a little brief about Sandeep sir. We are very delighted to have Mr. Sandeep Sharma, our esteemed mentor and a distinguished industry expert from Tech Mahindra. He has a experience more than 2 decades of experience in telecommunication domain, and he has been a key leader in driving innovation across applied AI, NTN, Open RAN, cloudification, and network virtualization. His contributions have played a significant role in shaping AI driven network architectures and advancing towards 5G and 6G implementation. And it's an honor to have him guide us through today's webinar. With this, I would respectfully invite Sandeep ji to begin with the session. And at the end of the session, we will be taking a Q&A from the participants. Thank you.
Thank you. Thanks, Anushri, for having me here. I think the topic is very much relevant, and welcome all the participants who managed to get some time to listen to this webinar. The thought of behind sharing this webinar is not something which is more technical. What I thought of sharing is predominantly more around what industry is looking today and what industry expects out of the use cases as we go further. And the topic I thought of sharing today's viewpoints of mine is more around how we can demystify 5G, and when we evolve towards 6G, which all things we should take care while creating real time life use cases, which actually uses 5G and 6G rather than limiting ourselves to certain boundaries. Uh, if you have any questions from the audience, which you feel is must to answer so that you can continue understanding the slides, feel free to write your question in the chat or interrupt me wherever you feel like. But if it is more a discussion oriented question, we can take up those questions in the end of the presentation. I think if you look at today's scenario, lot many startups or the use cases that are being created in the industry, everyone is focusing on how the 5G is being used. Some use cases that are being positioned in industry, at times when I interact with different I would say industry startups or the use case providers, I feel basic things are still missing before saying that use case is true 5G or a 6G. But let's understand where we are heading towards this technology evolution so far. I think every generation in any technology, be it telecom, be it energy sector, or be it compute industry, where hardware is so much of part of the, I would say, not only the hardware, software is also too much part of the ecosystem, or the technology is part of that technology ecosystem. So every generation starts with too much of information, right? Which gives a wow factor to each and everyone, like be the industry person or the persons who are consuming those technology, a lot of attention to it. So everyone feels, okay, this is coming in, it will change the whole paradigm, things will evolve. But slowly you see the attention is getting normalized to reality. Then we align ourselves, okay, this we overthought of it, but actual capability that can be realized from this technology is something which is suboptimal, not the peak that we have thought of. So we call is an attention curve. So we got lot much attention to give lot much attention to a technology in the start, and then we normalize it, and then stabilization phase comes in the picture. Second is the adoption curve, which is called the S curve. Whenever there's a too much of hype initially, there's always a less lack of ecosystem as well, lack of hindrance as well, whether we should go with the direction or not. So adoption of new technologies always comes with a very little uptake. But slowly when the things get normalized, acceptance, expectation from the technology attains like the stability or the ecosystem equilibrium, then the adoption started going to start. And then you'll see the adoption started to rise exponentially, and then reaching in a horizontal, which is a stable part of it. Then technologies continue for some time. And after this adoption cycle and attention cycle, another generation will come in, then you see a new curve coming in, you see the decline of the previous technologies. This is a typical curve. But what happens in these transitions, at times, what makes certain organizations or the startups successful, who understand the technology from the attention phase to the adoption phase, and find out which all things they should consider to make a product which is more sustainable in a longer run. If you look at different technologies evolved over the years, so I started my journey in 2G. Then there was a lot of given understanding that 2G is a successful technology at that point of time. Then 3G comes in, then 4G, 5G, and now we are talking about 6G. But over these generations, who have, I would say, encountered more deeply in these technology domains, or used these, I would say, connectivity ecosystem to evolve their, I would say, end use cases. If you look at 2G and 4G, they were quite, up till 4G, it was quite stable technologies and things were evolving very fast. There were consumers around it, and the business uptake was quite good. There's a reason behind it. What has happened? Why it was so smooth with the earlier generations? Let's start with 2G. 2G, there was a basic need in the society that people want to communicate long distance. It was a need. Humans wants to talk to each other. So the technology was satisfying a basic need, which every human is consuming. So by the time technology comes in, we started consuming it as it is. When 3G comes in, by the time 3G gets popular, more and more data centric things are getting positioned. By the time there's already another technology evolution that has happened called television. And we are so much habitual of watching videos over TV that when it comes handy on a mobile phone, that gives us a good feel, and we got adapted to it. So every technology from 2G to 3G, there's a consumer pattern which is already defined by the other, either the human behavior or the which is another technology is propelling it. When 4G comes in, by the time high definition content on the TVs, smart TVs also getting popular. So we started consuming more and more videos, which is very high definition. We started getting many application centric use cases as well, because the bridge between a mobile as a communication device to mobile as a compute device or a personal device is getting more and more narrower. So people started taking 4G as more a personal entertainment, personal working device, and laptops are getting smaller and the screen size of phones getting bigger. By the time 5G comes in, there are new things that got positioned, right? We started talking about immersive experience. We started talking about ultra reliable low latencies, and most importantly, the industrial use cases around it. But by the time we started positioning 5G around these use cases, industries were not ready for it because there was no inherent need that these industries have thought of having a more stable or more innovative use cases. They were very well satisfied with the previous generations, the way they behaved in the industry from the other technology verticals. Maybe a Wi-Fi was sufficient for them or a wireline was sufficient for them. And that's the reason we see less uptake happening around the private 5G use cases initially, because industry were not used to these type of inclusion in the industrial use case. But things are picking up in 5G now. So from 2G to 5G, it was more how we can improve performance, how we can incorporate new use cases. But when 6G is coming in, I think most of you might be reading around it. A lot many things are discussed, how 6G should look like. Standards started their work together. And most probably the initial release of 6G will be there either in the early 29 or the late 2029 time frame. But we don't want to do the same mistake that we did with 5G. 6G is going to be much more diverse compared to the technology that we have thought of till 5G. 6G is going to be AI native. AI native has its own narrations, but having every node, every component having their own intelligence, and that intelligence is coordinated across the network will generate to new use cases. We'll talk about more around 6G as we go further. But the important change that is happening now is additionally with 6G coming in, AI as a traffic in the telecom or AI as a use case or as a need is already being positioned in industry. So almost all of us will be using or are using AI at least 10 to 15 times in a day, minimal. Either using using it for inferencing or using it for searching anything. The transition from web to AI based query is getting more and more popular. So networks will see, or the industry will see, a new type of traffic, which is AI traffic. If you look at the philosophy that has evolved in a summary, pre-5G philosophy was more about consuming voice and data over or the text over a network and use it for certain use cases. 6G is more about how we can bring intelligence in the network, how we can incorporate capabilities like sensing. Sensing is something you can use the same communication channel for communication as well as sensing the surroundings. It could be sensing the traffic patterns, it could be sensing the pollution systems, it could be sensing the surrounding objects. There are a lot many use cases that get evolved with this sensing capability if we do it rightly in the standards. Thirdly, the convergence of terrestrial network, the typical cellular networks, and the non-terrestrial network. Typically, we always think about when we say non-terrestrial, it's only satellite, but there are apps, platform, drone, everything comes into the NTN type of everything which is above the ground can be used for a communication, but it is now more integrated to the standards of 6G. So we need not to think of separately. In today's scenario, when we create a drone use case, we think of incorporating drone over 5G, but 5G treated normally all these channels either as a data or a low latency communications. There's no standard coordination that is happening, but with 6G coming in, all those convergences are predefined, so it will be more smoother integration, more, I would say, efficient use cases that can be realized. Having said that, 6G is not only about intelligence. The previous generation use case will continue to exist. Some will get diminished, some will get more popular, or some will get a flavor of the enhanced capabilities. If you look at today's scenario, when we have seen so many of 5G use cases, I think almost all the time when you try to solve a problem, you need to understand whether by solving this problem you are making use of available, uh, I would say, uh, contours of technology correctly, or you are using it just as a connectivity path. If you are using using the 5G for as a technology for any of your current problem statements, and you are not realizing the full potential of 5G, then I would say it's not a 5G use case. You are just using 5G as a connectivity. When we say capabilities of 5G, when 5G got introduced, there were three main dimensions on which 5G was positioned. First is it is here to enable enhanced mobile broadband. When we say enhanced mobile broadband, the data rate should be in the range of, or the data consumption in the range of hundreds of Mbps or Gbps. If we are creating any use case which is more centered around few Mbps, we need not to have a 5G around it. It could have been done on 4G, right? So think of your problem statements when you're creating a use case on 5G, which are very, very data hungry. Then only you need 5G, because ultimately every use case has to have an ROI defined. If you are consuming a very big pipe for a small water flow, I think the cost of the pipe is not justified over there. So when you're thinking of any problem statements to get realized in real world, think of the scenarios where very extremely high throughput or extremely high capacity is needed. Second dimension is ultra reliable low latency. Ultra reliable low latency often, I would say, misunderstood only as a low latency. It's not. So it has two dimensions. You position your use cases where low latency is critical on the order of 5 milliseconds or 3 milliseconds. At the same time, it has to be ultra reliable, achieve maximum possible nines of reliability. Those type of use cases will make sense of using URLLC. And typical example of these type of use cases is maybe when you are using in situations like of emergency response, where every second delay or every millisecond delay makes a lot of impact on human life. In the robotic applications in healthcare industry, if we are creating a healthcare use case which is actually interacting with human body, the delay in the network or latency in the network has very large implications that we can think of. And human life is the most important aspect of our existence. So we should be thinking of those use cases if we are looking at the URLLC dimension of 5G. Don't only look, if you are creating a, I would say, healthcare industry use case, which is not time reliable, not coverage reliable, then it is not the actual healthcare use case. It is just a connectivity use case if these parameters are not critical for a healthcare industry. Third is massive machine type communications. Creating an IoT use case on a 5G network, if your I would say IoT devices expectation to grow not exponentially in the near future or a long future, then 5G is overkill. Think of use cases which require extremely high density of sensors, so that once the need of that scaling needs to come in, the 5G is the right technology. Then start investing time on it. If you have any use case that you feel is good for 5G and you feel that you are not well convinced how the 5G will be helpful to them, to your use cases, feel free to reach out. Happy to help you understand how 5G is critical. If it is not, we should use alternate technology which can make your ROI on those use cases much more efficient compared to investing in a costly infrastructure. So these are three dimensions, and these three dimensions create infinite possibilities till the time we thought of 5G. But our, I would say, duty is to use the right combination of these dimensions before investing time and energy of creating any use case for 5G. If we go further, if you look at why there was so much of confusion around it, and I'll correlate more with the initial hype cycle that we have seen in the start. Initially, we put so much of energy on speed focused marketing. 5G was because we moved from 4G, so everyone thought, okay, 5G is about next level of speed, and we misunderstood or not understood as an industry that there's a more use case around low latency and other things could be realized in a much better way because we have not experienced those type of KPIs on a telecom network. Secondly, the enterprise who are positioned as a main consumer of it, they were not educated enough. They don't feel that they need a 5G as a system. The other dimension was that the ecosystem was fragmented. The technology comes from the network perspective. Devices always comes with a lag. For example, the phone comes in, but the sensors and camera industry, those were working in the pre-standard era of only for those small industry or the large industries, and they were nowhere interacting with the telecom standards. So there's a huge, I would say, gap that we all as an industry identified. Okay, sensors are not there. How the network is going to realize these type of use cases? But the 5G sensors or 5G cameras are now getting available in the in the industry now. Next is we used buzzword so much that at times end consumers get confused why this buzzword is. For example, if you go to an industry, say we will use URLLC to satisfy use case for an industry. Industry don't want to get confused with it. They need simplistic solution for their problems. So as a use case creator, as an industry, when you go to an industry, you should explain them in the simplistic form. URLC is just to make your use cases, which are very critical, more stable and more efficient. Then they will understand, okay, what type of efficiencies that they will get out of it, rather than going too deeper into the technical domains. Lastly, there were too many adjacencies were also present, and not at the time of so many of adjacencies, even the startups who create those use cases or the industry who consume those use cases that get confused. There was a Wi-Fi, is a Wi-Fi, there's 4G as well, there's a 5G comes into picture. Then when you have so many options of realizing use case, people get confused. That's where your fundamental of sticking to the basics always help. It will help you realize which use case for which technology for which cycle of the consumer we should look or focus into. Some of the examples that I thought of sharing with you is like, if you look at the technical considerations that needs to be positioned is the latency requirement, but where it should be positioned, it demonstrates the end-to-end latency. Like the moment you send a request, how fast it comes into, whether you need these type of latencies or not. Typical examples where if you are in a robotics use cases where less than 10 millisecond latency is critical, these type of use cases will be helpful of going into ULC use cases. Or if you have any camera based application where you have a latency requirement of processing or analyzing the data in the range of 30 to 50 milliseconds, then it's a 5G use case. Else, the higher latencies could be achieved on 4G networks as well. So either a high throughput or a low latency. If it is too much of high throughput that needs to be analyzed, then it's a 5G need. Uplink and downlink balance. So there's always an uplink where you send a request and downlink when you receive the data. So there's always a traffic disparity that keeps on happening. Sometimes in the surveillance type of system, you get a lot much of downlink or uplink data. And at the same time, some time of AI is being run on the camera side itself so that you get a meaningful output around it. So there's a high variation of traffic that will happen. So you need to position those type of use cases as well, because within 5G, you can define your frame structure in such a way. If it's uplink heavy, you can dimension more on uplink. If a downlink heavy, you can dimension more on downlink. Third one is the URLC. When you have a high amount of reliability of 5 nines, which is required, typical example is of when you talk about the dark factories where some of you might have seen the news where all the robots are maintaining or doing the operations. Some of the examples from the China and other countries, that humanless factories where all robots are doing all the work. These type of scenarios where lot much robotic environment is there, then there's a need of the high reliable communications. Similarly, more and more use cases that you can envision, but looking at what benefit that you are getting from the technology. Third is, as a startup, this slide I always position when I talk to startups or the idea pitch forums. There's always a choice that you get when you're going to startup mode. Either you can focus or use the technology to create an end user or in consumer case use cases, or you can focus more on what's missing in the current technology and go in a deep tech startup or creating either a new technology or creating an adjacent technology that can enhance the performance of the current technology. Typically, and consumer type of use cases, startups have a early access to revenues. Typically within 3 to 12 months, the product gets ready and you can get faster pilots and you can get access to revenues as well. But there's always a chance of getting these type of startups getting replicated. That's the reason you find so many of food delivery applications getting popular, and almost all of them have the similar mechanism. Second is a deep tech startup where you focus so much on R&D, you invest time, energy, and it's always a longer cycle, typically 2 to 5 years. But the benefit that you get while going to deep tech startups or technology startup is that you get access to IPRs. And IPRs is just like investing on something which will give you continuous return over the next multiple years. And those type of IPRs, if go into standards and become standard essential patents, then it's like royalty by default will keep coming, and you can continue to use this technology for your own. You can license it further. So the business models vary differently. So when you position or when you address any situation in your current landscape, think of which direction you want to go as a startup. And when you think of something, then you need to position or you need to dimension what type of I would say resources which are available to you and how you want to scale it. Those are different parameters beyond technology that you should consider while creating or evolving towards the next idea or a startup creation. Now comes the 6G. 5G, we understood a lot many things were available. We could use it, we could leverage it, but 6G is going to be the next leap, the way we think the network will be. In the previous 5G, we thought of 3 dimension of enhanced MBB, URLC, and MMTC. So these 3 dimensions will continue to enhance, will have higher amount of capacity, lower latencies, and much higher, I would say, throughput capabilities, typical to any generations when comes as the next. But the 3 things that get evolved is the AI integrated communication, where intelligence is part of the network, sensing is also indicate part of the communication network, and ubiquitous coverage by integrating a terrestrial and a non-terrestrial network. So it will create a whole new platform. You can use different dimensions now. And these 6 dimensions either can be used independently or a mix of each other. That creates a new matrix and maximum possibilities that can be realized, a maximum, I would say, use cases realization, which we thought or we feel are not possible in today's scenario. These capabilities needs to be harnessed in full sense. And when you're doing any use case in 5G today, try to analyze if any of these KPIs is missing in today's use case of yours, and it could be a value add as you go further. So whenever you're creating a business plan for around any any use case and how you should position it to the industry is like, think of what can be done today with these use cases, what type of market you can address, and by the time 6G comes in, this use case can further enhance to provide these type of advantages, because 6G is coming up with these type of capabilities. With 6G coming in, as I said earlier, the new type of traffic is expected, new paradigms will going to come in. One is the AI traffic. Many multimodal traffic will come. And if any one of you have seen the Elon Musk interview, I think the more and more traffic in the network will be like video AI, where videos are being used to generate context, and context will again generating a video. So video traffic propelled by AI will see the future. More and more AI based use cases will get realized in the network now. So you need to look at not limiting yourself with the way AI currently today is, or the way you look at AI today. Keep on investing time and energy, how the different AI use cases could be best leveraged on a telecom network with the capabilities that 6G is being positioned. Thirdly, sensing. Sensing is still some form of sensing can be done in the traditional networks as well. But to sense nearby surroundings, more and more capabilities will come in 6G. Start thinking of use cases where you need to sense the surroundings, and then start working backward. Finally, convergence of different technologies. If you want to create a use case where you need a continuous connectivity across the globe, then you need to look at the convergence of terrestrial, non-terrestrial network, or something which is more economically viable if it is getting a continuous coverage or continuous connectivity. Think of those use cases while we are looking at the dimensions of 6G. However, having said that, the conversational voice, video, and data will continue to coexist, but their dimensions or their form will change or evolve further. This is just a snapshot of one of the white paper that I read recently from Nokia. The traffic pattern of each and every AI applications is different. The type of throughput or type of capacity that they expect from the network. If you look at the purple shape, it is for the chat and conversation. You see, it is immediate high spike, but it's not spread for a longer duration. So this type of traffic will create spikes in the network. If you look at document generation, it will not create spike, but it will sustain for uplink downlink traffic. There's a different distribution. If you look at image generation is not putting so much on the uplink side, but it is spreading or consuming so much on the downlink sides. So traffic patterns are also changing. This is basically a snapshot that the way traffic is handled in today's network is not sufficient to handle the traffic for AI-based application on a telecom network. These type of ideas will give you an idea if you're going in a deep tech mode of creating any ideas or creating any solutions for 6G, what type of deep APIs you need, at the same time, what type of IPRs you need to create, you need to for the position in terms of research. And if some of your ideas will really get into shape, it could be part of the SCPs and ultimately the better returns of your hard work and intelligence you put into the system. This is a brief summary that I thought to put. When you analyze those use cases, understand what is possible in today's scenario. For example, low latency is robotic communication. 5G latency is around in the range of 10 to 30 milliseconds, right? But if you go to 6G, you need to have the use cases which is more and more realistic or deterministic. Then there you need to position if a robotic type of low latency communication which needs more latencies, then how technology should be changed. For example, you need to have AI native MAC schedulers, or you need to have synchronization which is at the microsecond level, not the millisecond level. Similarly, if you're going for a video analytics thing, there are a lot many things that get changed over the network and that can impact your network significantly or use case significantly. how we can positions more and more on the uplink centric architecture in 6G. Similarly, the integrated sensing in communications, how we can position sensing as a positioning requirement as well. If you look at today's scenario, the nearest, I would say, position accuracy of locating a user or any device is in the range of meters with 5G. But when we incorporate 6G, where the sensing is can be done simultaneously on the communication channel, you can sense to the nearest possibility of centimeter level. Then these type of sensing will create a better ecosystem for taking time critical or position critical decisions. So positioning will be much more accurate. Any use case which require precise positioning, then 6G could be a better use case or better use technology for that use case. So the overall conclusion is that every technology has a vast potential. It's up to us how we are leveraging it, how we are using the best of what is available rather than using the past understanding and overkilling the current technology capabilities. Think forward looking initiatives and then put those use case on the current technology. Innovative use case realization possible, but we need to have a clear understanding of the underlying technology as well so that we can realize the best potential. Explore limits of both the current 5G technologies and think of what can be positioned with 6G. Don't limit yourselves with a few specific use case that you find the industry is doing. India is a very diverse country. We have much more diverse problems, and when the diverse problem is there is an opportunity to create diverse use cases. We may drive many things in the standard itself if we create technologies which are more centered around India. There's an equal opportunity both for the use case and the deep tech startups. It's up to us, up to our resources, which we have to harness and define, design, and dimension the path for our idea or the startup that we want to work on. I think that concludes my session. If anyone wants to get connected, I'm quite active on LinkedIn. Happy to respond to your queries if it is anywhere aligning with the deep tech space or utilizing the telecom networks.
Thank you so much, Sandeep sir, for sharing your valuable insights. And basically, this session was very informative, and we really got to have an understanding how the 5G, 6G landscape is basically evolving and how does it open possibilities to both innovators and for the industry here. And we truly appreciate your time, guidance, and your support to our 5G, 6G COE. So, any participants have questions, we can take them. So, there is one question in the Q&A session from Ityash Ahmed, and he wants to understand what does we mean by 5G camera and how 6G camera will be.
Yeah. So it's a good question. So cameras are not 5G or 6G. So cameras are 5G enabled or 6G enabled. When we say 5G enabled, 5G enabled is actually that you can utilize of transferring the camera data in a much faster and much reliable way, or the camera is utilizing the network in a stable environment of the network. With 6G coming in, there might be certain cameras who can do local AI, and though how that local AI inferencing or the model training could be moved faster to the network and how the network capability could be best realized. So those typical cameras who can realize the 5G, 6G capabilities are basically positioned as 5G capable camera or the 6G capable cameras.
Thank you, sir. Sir, I also have one question. Sir, how does this 5G, use case look like in uh, power stations or, in substations? Because you mentioned that in hospitals there are critical point where health care people should basically try to monitor that the critical time should be there and should be reliable. So Is it true for, I mean, the substations or the electric um, domain as well?
Yeah, I think within the electricity environment, electric domain, if something which is, for example, the areas where human interface with the technology is critical, right? So if the people are touching those switching systems and all, they should be fast and accurate. I would say reporting of it is needed, right? Handling of those devices would be time critical. Having said that, lot many sensors that only judges or monitors the power consumptions, they may not be requiring the 5G capability as such, but they may be utilizing the IoT capability or the massive machine type communication capability of 5G, not the latency one.
Okay, sir.
5G is applicable to them, but not the low latency one for all the use cases every time.
Thank you, sir. So there is one more question he's asking, Ityash Ahmed. Is there anything like AI-enabled camera, like digital camera, to which we can interact as with ChatGPT, as to what is going on CCTV? I mean, can we connect the AI-enabled camera to interact with Gemini or ChatGPT? Basically, he's asking that.
Yeah, that can be very much possible. I think it's like if you are running a multimodal interactive portal on a camera, then you can raise your queries as well.
Okay, sir. Thank you. So there is one more question from Bheem Singh, Coal India, IIT Jodhpur, and he's asking that is it true to say that end use cases startup seems to be feasible as compared to deep tech startup, especially as some expert say industry big tech firms are not keen for ORAN like open technology. So are you able to see the questions?
Yeah, I can. Yeah, I can see the question. I was just reading it. So it's a good question, Bhim. It's always I would say uh, if and or type of question, right? End use case startup is easy to go into the live market, but their life cycle is very small. May or they may scale or they may not scale. But the deep tech startups, when for example someone say, okay, Oren technology, it's not up to what they have thought of, but while creating an Oren technology, the industry has transitioned to a common understanding that interface can be opened, the compute can be virtualized, and those type of capabilities which are typically thought of, I would say IT network could be leveraged equally well in the telecom network. In this process, lot many IPRs that got generated, the industry is getting benefited out of it. But big tech firms are, I would say, they spend too much time for any technology, for example, Open RAN, to remain in that, I would say, attention phase. But the stabilization is coming in, and that we see a lot many companies are, or the established companies are transitioning towards Open RAN. So open, and if you look at the discussions that are happening around 6G as well, 6G is destined to be more and more virtualized and more open, and I think that's very well justifies that operators or the companies who invested in ORAN standards will get more benefits when the 6G comes in.
I hope that answers your question, Bheem. Thank you so much, sir. I think, sir, now no one has any questions. Is there any participant? Sir, I think now we can
Okay,
close the webinar. Thank you so much,
good.
sir.
Pleasure. Thank you.
Thank you, sir.